Okay, next up, I'm pretty sure
Ouros.
we have got Ouros.
Yeah.
Ouros Materials.
Teresa.
Teresa, right?
Yes.
Hey.
So,
Hey.
Nice to meet you, Owen.
Nice to meet you.
hey, Martin. Nice to meet
Nice to meet you.
And we also have Sharon.
Yes.
Yeah.
Hi.
Nice to meet you, Owen.
Nice to meet
Hey,
you.
Sharon. Martin. Hey.
Hi, Martin. How are you?
Cool. Okay, we've done the names. So tell us your roles, and then we will get into what Ouros is,
Sure,
etc.
awesome. Yeah, I'm Teresa. I'm the CEO and co-founder of Ouros.
And I'm Sharon Tracy. I'm the CTO of Ouros Materials.
Very cool.
Yes.
What is Ouros then?
What does Ouros do?
Yes.
Yeah, so we are a materials platform technology that's developing fire resistance, carbon storing composite materials for the built environment.
Are they structural materials or non-structural materials?
Yeah, so we're commercializing out of a concrete lab. So they're like 3 times stronger than concrete. So we know they're definitely structural capable, but we're starting off in easier areas. It's a little hard to convince a building owner to use a new material in a structural application.
And the codes don't
Exactly.
do not predict them, so you need to probably
Yeah.
convince the regulators first, and then.
Yes, yeah. Our first markets we're looking at, exterior fire resistant panels, so like sheathing, siding potentially, as a way to solve the issues around like wildfire performance.
Oh, so it's not just concrete? Am I?
It's a
materials.
Would you like to see it?
Yeah.
100%. Wow, you come prepared.
Yeah.
Damn, look at this. Here we go.
And it's been CNC machined.
It feels like a
Ceramic.
porcelain, ceramic. Yeah.
Yeah, so it's a ceramic polymer composite. So it's mostly ceramic material, but it does have a bit of polymer to add in toughness and crack resistance. Yeah.
Very cool. Okay, so Sharon, maybe tell us how do you do this?
We're trying to keep our process simple, actually, to, you can imagine, keep costs down and make it reproducible. So we are currently mixing it, low shear mixing of the raw material. Then we're using a pressing technology. So think of compressing like a pill, for example. That's how tablets are made, so compressing it. And then there's some nice technology around the carbonation piece, which is where the magic occurs, where it goes from being green, if you will, if you've ever heard ceramic talk, like before sintering, and then, the final. Okay, it's fine if you didn't.
Yeah. My technical brain is like.
in the hardened material. Let's put it that way.
Okay, yeah.
So
That's better,
that's the cool
better.
part that Teresa mentioned. The carbonation piece of it happens in that step. And then it
Carbonation is to
becomes
make it stronger.
solidified. Yes.
Yeah.
Very cool. And so you mentioned like starting with like smaller applications, then branching out into bigger applications. I think one thing from speaking to a number of people that do building material like innovation, it is very hard to get commercial adoption. So maybe like how are you thinking about that? Is it true what you've described already, like through the starting small and going big, or maybe you can also highlight like how companies react, like are they initially very resistant, are they open to hearing, are they like too risky? Like,
Depends who you talk to.
And for what type,
Very much.
and what
Yeah.
type of applications you're doing? Yeah.
Yeah, so the way that we're going to market is starting off in like non-structural, low regulation areas. We've even explored interior applications like counters or decorative pieces, more as a way to just show the proof point that our material exists out of the lab. It's something you can touch and feel and like install in your office space. But ultimately, we want to enter an area that has a big market opportunity, like exterior siding, where we can really tackle some of these like core challenges around climate resiliency. So we view it as how do we install our product into these like couple different applications just to prove that we can. And then long term, our main goal is to partner or license with a major building materials manufacturer who can help scale our technology and really focus on like the manufacturing core competency, whereas we're more focused on the materials innovation side.
Into structural elements or not?
Long term, yes.
Yeah.
Eventually, once we, get proof points of the technology and make sure that we can produce it at quality and consistency.
he's a structural engineer, so he's
I see.
obsessed
Okay.
with
That's
kind of work.
Yeah, exactly.
The thing is that we've been designing buildings for the last 120 20, 30 years with steel, concrete,
Yeah.
timber, wood here, and we kind of don't innovate much
Yeah.
in this sphere. So I wanted to ask you why we don't innovate much in the material engineering, like general question.
I would say it's the key thing is durability and proof points. I mean, people don't want to be the guinea pig, and there's so much at stake in a building, people's lives, and you can't get on higher stake than that. So there's a lot of risk, ultimate risks that people, if you know how some things work and it's has 50, 100 years of understanding and you know all the mechanics and you can crank out all the calculations, it's really hard to change that for a new material that until you build up, it's a process, to build up the knowledge, build the mechanics of it. How does it behave under load? How does it behave in weathering situations? All these things then. And only then, and it has to be cheaper than everything else.
Damn. So it's like monumentally difficult. Like I think for material people to like find their way into an industry. So you have tough, thick skin to be able to do it.
It's tough, yeah.
You said I think the material is 3 times cheaper, or less.
Depends what we're comparing to.
Yeah, exactly.
Yeah.
So
Yeah.
what would you be comparing to?
So for example, in the siding space, one of the leading fire-resistant solutions is fiber cement siding, but that's like 2 times more expensive than what's the norm is vinyl. So our idea is that we can cut the cost of, say, a fiber cement siding alternative in half and be able to bring to the market something that's more durable and affordable.
How did you both get into this? Sharon, maybe you go first.
What's that?
How did you pick the CO2 polymer constructions? Like why did you get into this? How?
Polymer-based ceramic composite.
So this is one of those stories that it's a bit of a fluke, I guess.
Serendipitous?
Yeah, serendipitous. So I have a materials and a ceramic engineering background, and early in my career, I wanted to make tough ceramics. So that was there. I did other stuff. Teresa, of course, is over here, and she found this material. So that was Teresa that Professor Ryman had been developing in his career, and then Professor Ryman, who's our scientific advisor and the inventor of the material, he put the two of us in contact.
Oh, that's cool.
Yeah, and so then I was like, oh, that is really cool, and it just it just meshed with some of my interests, and I just thought that I could help Teresa with her idea to build the company, and so here we are.
Oh, nice.
Yeah.
Teresa, you?
Yeah, so basically my background's actually in big tech. I worked as a product manager and software engineer for a bit, but I've always been very climate focused and wanted to make a lot of impact and loved the idea of startups and technology and these like core inventions in the world. So during COVID, I explored a little and ended up in the climate space and got this fellowship with a foundation for 2 years that sponsored my ability to do a lot of exploration. So I was really interested in industrial decarbonization because that was like the tailwind of what needed to be solved in climate. And I was like talking to every researcher I could chat with who would respond to my emails. I was going into like community biolabs just to learn like how you create different types of green focused chemistries. And then I met Professor Rick at a conference in New York. And Rick is a huge visionary in the green concrete space.
Nice.
He previously founded Solidia, which was a huge company during Clean Tech 1.0 in green concrete. And he had this grand vision for how we're going to capture carbon into everything and how everything's going to have a green chemistry. So I joined him, and the nice thing is that Rutgers is literally the in-between of my hometown in Pennsylvania and where I was living in New York City. So I was like, wow, it's such a gem in my backyard.
Yeah.
And then it came time to like find a CTO, and me and Rick sat down and figured out, who is with our network that we'd be excited to work with, and then that's how the two of us got in contact.
Cool story.
Yeah.
I like it.
Yeah.
How are you thinking about go-to-market?
Yeah. So this is what we focused on during Boost. We, as a materials company, it's very nuanced because there's a lot of different strategies you can have at different time horizons. Like structural is obviously the long-term time horizon, but like how do you find a wedge, and like what is your goal at every point of the commercialization space? So the way we think about go-to-market is long-term we want to be, again, licensing and partnering with major manufacturers to be able to refine this material we have into their end products. And in the short term, we are focused on piloting our materials and really focusing on de-risking the technical and manufacturing scale up to a pilot stage, at which point we'll be able to have more in-depth conversations with manufacturers, sign a couple of key joint development agreements, and ultimately get to a first license where we have developed a first-time partnership where we integrate our manufacturing technology into theirs. And then from there on, it's more of like a rinse and repeat of licensing out the technology, staying in one key application first, but then slowly expanding over time as we improve our capabilities in the innovation space.
Yeah, very cool. And how has Boost specifically helped with that? My assumption, I think you mentioned that Boost was like a strong pull for you because of that commercialization aspect. So yeah, maybe you could give us some specifics on how Boost has enabled that for you.
Yeah. So the team is absolutely incredible. They all work super hard and have a very high bar for excellence. And I think what's really special about Suffolk Tech in general is their connection to dozens of industry partners and operating partners. Like for us, we've been able to sit down with Anderson, Amrise, Karas and Karas during a fire testing, and we literally went to a fire testing in live person where they lit their facades like on fire. It was like huge. It was like a 20-foot installation.
Oh, that's cool.
Yeah, I have videos. It's cool.
Yeah. Everyone loves to see destruction.
Yes, they do.
It was a weird type of fireplace going on. Smelled like kind of burnt plastic, but it's fine. It's great. But I think being able to get such a strong introduction from them where we could have more candid conversations with these manufacturers rather than, like if we cold LinkedIn DM or cold email one of these manufacturers, they're going to wave us off and you go into a call and you're like trying to impress them. Whereas we had some like really great in-depth candid conversations of just like behind the hood, like what do you actually need to see from a materials startup? What have you seen work? What should we avoid? What kills startups? And they were so open to answering some of those questions in like hour-long conversation formats, which was honestly so valuable because they are the ones to go to for this type of advice, right? So that was a huge help for us.
Yeah, very cool. Sounds good.
Well, so material engineering is very expensive, right? To do it. How you seeing like costs of development of the product and?
Yeah, so that's the nice thing about partnering with a university. So when I first started the company, it's in the materials engineering space. You either somehow front the load of research and development and like set up your own lab and experiment on your own, or you can partner with a lab like a university or a national lab that has already spent like hundreds of thousands, millions of dollars on their equipment, their facilities, their know-how, on their existing research. And so when I met Rick and we started commercializing the tech, there had already been like a decade of research on like this material and like a couple decades on the core carbonation process through Solidia. So we were able to build on top of this existing materials platform.
Great.
It was already at technology readiness level 4, whereas like other companies will have to
What does level 4
scratch.
mean?
It's just the technology readiness level is a way to gauge the maturity of a technology. So 4 is just proven at lab scale, where we've proven the core science in several prototypes, and now it's more a matter of translating that research into relevant environments and upwards of manufacturing scale.
Very cool. Okay, shall I do the challenge?
Yes.
15 seconds to draw a picture of your startup.
Oh.
I mean, what should we make a rule? You can't draw the sample you just showed. Think more visually.
Oh my gosh. Okay.
Okay, here you go.
Wow.
And time starts now.
Oh no. Oh, it's on me. Okay.
Oh, we need the countdown music. You know the TV program Countdown. Do you have that in the US? I don't know.
Let them focus.
This is some chemistry.
5
Oh
seconds.
my god. Oh no.
No, a little bit more. Now it's 5 seconds.
Oh god.
3, 2.
That's cute.
Cool.
That's cute.
This is
Oh,
what I
okay.
have.
Let us guess. Let us guess.
This is our co-founding team.
Okay.
The three of us.
In the lab.
This is a beaker, surprisingly.
Yeah. This reminds you of
CO2.
Simpsons.
CO2.
Yeah, CO2. core
That's the
piece.
element.
Yes. This is a panel.
Yeah.
This is a happy building.
Yes. Beautiful.
Not on
Brilliant.
fire.
I think this was the best one so far.
Oh, really? Thank you.
Yeah. I have
Good
to
one.
say, very good.
Yes.
Okay, Teresa, Sharon, thank you so much.
Thank you very much.
Awesome.
Good luck,
Thanks for having
good luck
us.
with the presentation.
Yeah.
You have to do that in like a
Thank
tenth
you.
of the
Nice to
well,
meet
like
you.
Thank
a
Thank
quarter
you.
of the time you just had now.
Okay,
So
awesome.
good luck.
Thank you.